image here, there is a land with a river that is moving with the land. So you see the main river and the tributaries there. You see the tributaries. So all these tributaries, what they do is they collect water over this land. So the area that is drained by the river and with its tributaries. So when the rainfall comes in, the runoff is taken to this river. So this river is getting water in this piece of land. So that is your drainage basin. So it's a very simple concept. So in the drainage basin, we have a source. Obviously, a source is where the river begins. The river starts in the source, and then I'm going to try and highlight the source for you. For those of you who cannot see it, there in the beginning, the red dot there, and also the red dot there. I'm not sure if you can see it, and also there. That is where your tributaries begin and where your main river begins. So this is where the river begins. So that is your source. And now the river ends in the ocean, which is your mouth. So that is when the river joins the ocean. That is your mouth there. This is where the river ends. So the drainage basin is actually the whole area from the source to the mouth of the river. That is your drainage basin. But now we do know that the river has got its own tributaries, which makes the river system. And then now the tributaries are joining the river, the main river. So for example, they are joining there. Can you see there? The tributary is joining there. Joining the main river. That point where the river is joining the tributary, it is known as a confluence. And then you have a watershed. A watershed are these red dotted lines. If you can see them here, the red dotted lines, yes, that is your watershed. The watershed is known also as a divide, and is also known as a head, because later on we are going to be looking at the headward erosion. The head they are talking about, it is this watershed here. So the role of the watershed is to separate two drainage basins or to separate two river systems. It is a high-lying area that separates the two drainage basins. Yes. And then we have a tributary. A tributary is then a stream. One name for the tributary is a stream, or is a small river that is joining the main river. If you look at this in the map work, you will see the main river. If it's a permanent river, it's going to be a thick blue line on the map, and the tributaries are going to be the smaller lines which are joining. Most of the time, they are going to be dotted lines because most of the tributaries are not flowing when it's not raining. So that is why the tributaries are going to be shown like that in the map. So that is your whole area, the drainage basin. Let's move on. Now, the following slides, it's also showing the drainage basin. Now we have defined the drainage basin together, that it is an area that is drained by the river with its tributaries there. And then we have got a catchment area. A catchment area, if you look at the definition there, it's an area over which rain falls and is caught by a drainage basin. I want to understand, learners, that if you go physically to a drainage basin, you are actually at the same time on the catchment area. It is the same area. However, the definition catchment area it focuses on the area that receives rainfall, that catches rainfall when it's raining. Your rain is going to be falling all over the area, and then that is the catchment area, and then this rain is going to be going straight to the river. So the rain is going to be going to the river, so drained by the river, which brings us the drainage basin. So basically, it is the same area. Okay, and then we have a river system there. A river system, as I said before, we are talking about this main river together with all its tributaries. Tributaries being these small streams that are joining there. These are your tributaries. And then the confluence, as I said before, it is this point where the tributaries is joining the river, the main river. All the tributaries are joining with each other. And then the watershed, as I've said before, look at those dotted lines there, those red dotted lines there. That is your watershed. It's separating two drainage basins. And how are you going to see the watershed here? Most of the time is going to be given as a dotted line there on the edges of the high-lying area. So that is going to be your divide. Yes. And then the interflow. Now the interflow is this area here. See this area here. This area is separating this river and this small river. It's a high-lying area, like a small hill, if you want to call it like that, but it's a high-lying area. It is separating two streams within the same drainage basin. Remember, do not confuse the interflow and the watershed. The watershed divides two drainage basins, but the interflow divides or separates two streams within the same drainage basin. So that is what the interflow is. And then you have got the source, as I said before. You see the source where the stream begins. And then you have got the mouth of the river, it is where the river joins the oceans. And then the runoff. Now, with the runoff, I know other learners, they seem to find the concept runoff to be difficult. I don't know why. But if it's raining and you can see water flowing on the surface, you are looking at runoff when that happens. It is a water that is flowing on the surface. It happens when it's raining. That runoff is the one that comes to the stream to feed the river with water. So, and then it's also referred to as a surface runoff. Runoff and the surface runoff is the same thing, meaning it's the water flowing on the surface. And then you've got infiltration. Now, infiltration, by definition there, if you can see the definition, let's look at the definition together. It is a movement of water through soil into the ground. Now, let's look at this thing thoroughly. I wanted to look at that arrow there. I'm going to try and make the water is getting in the soil. That point there, when the water is penetrating the soil, that is your infiltration. But now when the water is moving downward, now it has already penetrated the soil, the water is moving downward, the downward movement of water is not infiltration, that is your percolation. We say the water is percolating downwards, you see, but infiltration is when the water is actually entering the surface of the soil. That is your infiltration there. And then now you have groundwater. Your definition says water found under the ground. That is a fact. Groundwater is the water that is found under the ground. However, I need to highlight something for you because you are going to look at another definition right now, which is the water table. Let me just erase this first, and then I can give a clear picture for you so you can see what I want to talk about here. Okay, it's so simple to say groundwater is the water that is found under the ground. However, let me draw a water table for you so that I can be able to show you exactly what does this definition actually mean, because if you don't understand the actual meaning, you might actually confuse this with anything. Now, if this is your water table, the water table will also be a dotted line. And then now this area here is an area that is saturated with water. You see, every single part in the particles, there's no space, everything is filled with water. Now, and then this one, the top part of the saturated area will be your water table. Now, groundwater is not just any water that is under the ground. It is the water that is below the water table. That is what groundwater is. Yes, I do know that there's going to be water that is going to be percolating to come to the groundwater, but the definition actually refers to the water below the water table there. I think that is clear. Ms. Mpoya, you will let me know if there are any questions with regards to any of the concepts that we are talking about here. And then, as I've said, the water table here, it says this is the upper layer of the underground saturated rock. What is this saturated rock? This groundwater here is kept in a rock. This rock is called an aquifer. This rock is called an aquifer. This is a rock that can allow water to stay in, but cannot allow water to go down, which is at the bottom. The aquifer is impermeable. When we say something is impermeable, we mean it does not allow water to pass through. Yes, the permeability now, it is defined as the ability of the medium to allow water to pass through. The medium will be a rock, the medium will be soil. Just like we use the word precipitation, it includes rain, it includes snow and everything else. Even the word medium, it includes rocks, it includes soil and everything else. So it can be any of those. So if the medium can allow water to pass through, then that medium is permeable. But if it does not allow it to pass through, then it's impermeable. Let me try to see if I can demonstrate what I'm talking about to you. I'll try to see if I can draw something here just to make you understand better what I'm talking about here. All right. Let's say, let's get a pen there. Let's say I'm going to draw an aquifer there. Gonna draw your aquifer there. Yes. And then you can see in the aquifer, there's going to be some particles and some species and everything else there. And then water is going to be filling that whole area there. The water will be able to come in the rock because of the fractures, the spaces, the gaps are between the rocks, if it's a hard rock, or the spaces between the soil particles. The water will be able to get in there and fill in this whole rock. But now at the bottom here, the rock is totally sealed. There are no openings. The water cannot pass through. That is what I mean by passing through. So the water cannot pass through, which means this medium, this rock is impermeable because it does not allow water to pass through. But now here, between the spaces that you find in the rock that allow water to pass through, that is referred to as porosity. Now, the pores being the spaces between the grains. If we have, I'm going to try to make the soil grains to be a little bit bigger there and draw them there if you can see them there. if you can see them there, if now there are spaces between the soil particles, those spaces, they make your porosity. So I'm going to try, if you put in water here, water then will be able, let me try to use a blue color so that I can help you there. Now, if water is getting in there, because of those spaces, water will be able to pass through and get in and saturate the whole area. Why? Because it has got spaces between the pores that we refer to as porosity. However, porosity does not necessarily mean permeability, because permeability now will mean, can this water be able to pass through this medium? If the water can be able to pass through the medium, then that is permeability. Now, porosity and permeability, they have a positive correlation. By that, what do I mean? I mean, if you have high porosity, you also expect to have high permeability, because if the water can pass through, it also means that there are spaces in between the medium that has allowed water to go through. I'm not sure if that is clear enough, but I think so. Therefore, this rock that they are talking about here, it is this aquifer, which has got a bottom that is impermeable. Okay, let me try and see if we can move on. If there are any questions, please address those to Ms. Popia. She will alert me of them. Now, what is important now here? What is important here is to be able to identify all the concepts. You need to identify the concepts. Identifying the drainage basin. If you can see the river system, where the river system is lying, that is your drainage basin. Same as your catchment area. The river system, the moment you see a river and the small streams, that is your river system. Tributaries, these are the small streams which are joining the main river. Your confluence, the point where the tributary is joining the river, that is your confluence. Your watershed, it's a divide, it's high-lying area. High-lying area there, it's top of the mountain there, like a boundary of your watershed. Sorry, the boundary of your drainage basin. And then you have your interflow. Just look at two streams where, remember, these streams are meeting here, are meeting somewhere here, but before they meet, they are separated, you can see. So this area here, let me just, let me get a highlight laser here for you. So this area here is a high-lying area. It's separating these two streams. So that is your interflow. And then you've got your source. And then the source is immediately where the stream begins, that is your source. And then you've got your mouth, where the river ends. When you see the ocean, know you're in the mouth, just where the river meets the ocean, that is your mouth. Surface runoff. In these pictures, you are not going to be able to identify surface runoff. You just have to understand that when it's raining, water will be flowing on the surface. So that is your surface runoff. Infiltration as well. Infiltration, it might not be easy to pick it up when it's not when it's on the picture, unless the examiner has given you some arrows to demonstrate this. But if the examiner has given you arrows, maybe an arrow there that is going down, maybe showing that water is flowing, then you know that is your surface runoff. And the infiltration an examiner might want to give you an arrow that is getting in the ground, showing you, and then that is your infiltration. With groundwater, look for the water table. Look for the water table. The moment you see the water table, then you know you are beneath it, it's a groundwater. So as I said, the water table is going to be a dotted line. It's going to be under the ground. Then you know you're looking at the water table. Okay, that is how you identify these features there. Learners, let us move on. Can we now go to the activities, Ms. Mpoia? There's an activity there, activity 1 with a drainage basin. Let me try to display it for you guys so that you can be able to see it. I just hope that everyone has this activity. But let me see. Can we, Ms. Mpoia, are you there?
Yes, I'm here, sir.
Can you now take over for the activities, and then let's give them 3 minutes to do that.
Okay, so can you just slide through the activity?
Sorry?
Okay, now it's displayed.
Okay.
Okay, learners, can you?
I just want us to go together to the diagram. Let's say 211 says, okay, match the concepts below with the letter in the diagram. So if you can see, the multiple choice questions are kind of changing, learners. Now they are giving you diagrams of the multiple choice questions, which means you need to know your diagrams. You need to know your concepts to be able to do this. And you must understand that the concepts can make up to 30% of your paper. So there are a lot of concepts. So you must know your concepts. Okay, let's go there. So the first one, I'm going to highlight each and every answer to see where do we get it. They say the source, 211, the source, which letter there gives us a source. Look at B there. It's telling us where the stream starts. That is your source. So indeed, that answer there is B, which is most of the schools have got it right. Pick up to you guys. And then we have 212, the water table. I'm so impressed. People have just spotted the water table. It's a dotted line there. It's marked a G there. That is your water table there. So that is G. Yes. And then we have an interflow. An interflow, it's a point that is an area that is a high-lying area separating two streams. So there is an area that is separating that stream and that main river. So that is your A there. So 213 being A. Okay, 214, and then now with 214, most of you have got it right. Yes, that is your drainage basin there, and then it's marked up by C. I do know that other people are going to say, is not those dotted lines supposed to be the watershed? But the examiner is giving you the key there to tell you that is not the watershed. So it's important to pay attention when you do an activity or when you write an exam. Obviously, the watershed would be, the lines would be somewhere there on the edges of the high-lying area. All right, let's go to 215, the mouth. Now you have got the C here, and then you just look for the C, and then you know where the river is joining the ocean. That is your mouth. That is E there. So E. Okay. And then we have 216, the watershed. In this particular case, they did not give us the dotted lines for the watershed. I assume they did not want to confuse you, but you can see the highline area there that is separating the two river systems. This is a river system here, and then this is another river system. So that highline area there is separating these two, so it's H. So that is H. And then you have a confluence, a 217, a confluence. Obviously, we must look. It's a point where two streams are meeting. One stream and one stream, they're meeting there. So D is pointing at the confluence there. So we have D. And then lastly, we have 218, the process of infiltration. There it is at F there. That is F. Okay. Congratulations to all of you. We've got these answers right. I think now we are going to move on. Okay.
Mr. Kundra?
Hello?
We have Fulani Tech, Delft High, and Fairdale number 2 high school that have correctly answered the question. So I'd like to congratulate them. Keep up the good work.
Thank you so much, guys. Thank you so much. You're doing great. We just pray that at the end of the exam, you can continue where you stopped. Okay. I think I should be able to move on now to another slide. Okay, let's see. Thank you. Okay, now we are going to be looking at the river, the types of rivers. This concept is very easy, learners. It's very easy. You just need to pay attention to the things I will highlight for you. Now, we have a permanent river, which on the map is also known as a perennial river. And then you've got a periodic river, you've got an episodic river, and you have an exotic river. Now, I'm going to highlight for you the difference between these streams. Firstly, let's go to the permanent river. I want to try to use a clear color, yes. I want you us to look at there on the water table there. If you can see the water table, can you see where I'm putting the marks? That is your water table there. This water table there at the bottom, it is the water table during the season where the rain is low, né? And then this water table here on top, the small dotted lines, it is a water table where the rain levels are high. So which means here, when it's raining, recharge is happening. By the way, for those of you who do not know what is a recharge is a process where the groundwater is filled up again. So just like when you're pouring water in a glass, the levels are going to go up. This is what is happening under the ground. When it's raining, infiltration happens, and then the water comes to the water table. The water table is going to go up, it's going to rise. Now, another thing I wanted to notice, the riverbed. Look at the riverbed there. For those of you who do not know what the riverbed is, that is your riverbed there. The riverbed. Now, why is that important? Another thing is, we must assume that this riverbed is a natural riverbed, because sometimes rivers can be canonized. To be canonized means they can put a cement on the riverbed to control erosion. But in this case, we must assume this is a natural riverbed for the processes I'm going to talk about to be able to happen. Now, let's go and explain it. All right. The water table is close or has attached itself to the riverbed. What does that mean? That means the water is coming from the groundwater into the river. So which means the groundwater is feeding this river with water because the water table has attached into the riverbed there. Same applies to this other one, the top one. The top one is even higher. So the groundwater is getting inside the river, which means this river here is receiving water from rain, is also receiving water from the groundwater. So, which means it does not only depend on rainfall for it to flow, it depends also on the groundwater. When the season of the rain is low and when the season of the rain is high, the water table continues to be attached to the riverbed. So what does that mean? This means this river here is going to have water whether it's raining or it's not raining. So as a result, it flows throughout the year, this river. And then now it's found on the east coast of South Africa most of the time. All right. I hope that one is clear, learners, but you are going to state if it's not clear for you. And then now let's go to another type of river, which is a periodic river. You also know that when you talk about period, it means it's going to change and change and change. Same to you. You have a maths period, you have a geography period, and all the stuff. So, which means there are some changes that are happening there. So this one, it will only flow through a rainy season. Why is it flowing through a rainy season? Because let us go back again to the water table. Look at that water table there. If you can see what I'm highlighting there. That is a water table when it's not raining. During the dry season, when it's not raining, the water table is going to drop, it's going to go up, it's going to go down. And then if it's going down, there is a gap between the water table and the riverbed. Now, what is going to happen when there is that gap there? The river is going to lose water. Instead of gaining water, it's going to lose water because there is infiltration will continue to happen there. The river is going to lose water to the groundwater. So if it's not raining, this river is going to be empty. But if it's raining, the water table is going to go up here. As you can see, the water table, this represents the water table during the rainy season. So the groundwater will be feeding the river with water here. Yes, so which means this river is going to flow when it's raining on the rainy season. So it only flows on the rainy season. For an example, this one happens in the interior of the country. We all know that the interior of the country receives rainfall when? In summer. And then in winter, it does not receive rainfall. So that means these rivers in winter, they're going to be dry. They're not going to have water. And then in summer, these rivers are going to have water. Those of you who normally go to the Eastern Cape, you can see this. It actually happens there. All right. And let's go to the other one, the episodic river. I always call it the episode because it just explodes when it's raining, and then when it's not raining, it's done. All right. The episodic river does not benefit from the groundwater in any way. When it's raining, when it's not raining, the water table does not come to attach itself to feed the stream or to feed the river in the riverbed. So it only depends on the heavy rainfalls. Remember, why do they say heavy rainfalls? Because Soft rainfalls cannot give you a runoff most of the time. It's gonna end up to the infiltration. So during the heavy rains, then you can have enough runoff to get into the stream or to the river. Then you can have that river there flowing there. The Western Plateau, you find this river that is closer to the western side of the Western, so to the side of the Western Cape. You all know what the plateau is. For those of you, you've done this in grade 12, sorry, grade 11, also in grade 12, even in grade 10, you looked at this. So on the western side of the plateau. All right. This one, it comes quickly during the heavy rainfall, and then it disappears with the rain. So yeah, all right. And then we've got the exotic river. The exotic river, it's much more similar to the permanent river because it is going to flow even in dry areas like desert, for an example. You'll find a river flowing in the desert and you ask yourself, is not the desert supposed to be dry? Why is the river flowing here? That is because where this river is coming from, on the source, that's where the river is coming from, on the source. It is a wet area. It's a wet area because it can be having rainfall throughout the year. Or it can be an area that is fed, just like the first stream we talked about. It can be an area that is fed by the groundwater. So therefore, this river can be able to flow even through dry areas and not lose water, because from its source, it continues to get water. I don't know if that is clear. So now, the example of these rivers is our very own Orange River. We know that the Orange River is coming from the Lesotho Highlands. And then we have got in the North Africa, we've got the Nile River, which ends up in Egypt. So these rivers, both of them are crossing through the desert. This one, Orange River, will come through Job, Gauteng, and then through Northern Cape, which is, we know, we have got a desert there, and then it will go out. And then this one goes through the desert as well. And then but these rivers these are big rivers, by the way. They have a lot of water because where they're coming from a wet area. All right. What are the most important things to remember? You need to know the name of the type of a river. You must be able to name it. That is permanent, exotic, periodic, episodic. You must describe the type of a river. By describing it, you mean it flows throughout the year. And then you must give the examples being where you find it, or if you know example of a river like the Orange River, or you can maybe tell us it's on the East Coast or it's in the interior. And also the height of the water table. It's very important because the examiners will want to know why is the river flowing during a rainy season only. Then you know that the relationship between the water table and the riverbed there. So that is the water table high enough to be attached to the riverbed, or is the water table far low that it's not connected to the water table? Yes. Okay. I don't know if we do have any questions there.
Yes, Ms. Kunja. Mr. Kunja,
Yes.
we do have a question from
Yes.
Owam. The question is, on periodic river, how can we receive rain on summer instead of winter?
Okay. It just depends on where you are. Remember, this one is found in the interior. I know learners from the Western Cape, they don't register in their mind that most part of the country is receiving water, rainfall in summer. The interior and the eastern side of South Africa is receiving rainfall in summer. So when you are in the Western Cape, then you receive rainfall in winter. So if this river is in the Western Cape, obviously it's going to be flowing in winter. But if it's in the eastern side of the country, it's going to be flowing in summer. I'm not sure if
Thank you,
yes.
Leonard, for the participation.
Thank you so much, Mama. Okay, we are moving on now. Okay, we are now moving on to we are going to be looking at, can you see the display? Can you confirm you can see the display? The new slide?
Yes, we can, Mr. Control.
Okay. Now we're going to be looking at the stream patterns, the stream orders, the longitudinal and cross profile of the rivers, the fluvial landforms, and the stream piracy and rejuvenation of the river. Now, the pattern, great learners, is the pattern is a shape. So, which means with this one, you're going to have to be able to identify the shape. How does it look like? If you remember the 5 geography questions, what is it? How does it look like? Where is it? How does it affect us? How do we manage it? So the patterns are shapes. You cannot be dealing with shapes and you do not know how to identify them. You must be able to identify the shapes. And we're just going to dive straight to them. Okay. Now, this diagram here is showing you multiple stream patterns, which the first one is this one. I'm going to highlight it for you. Okay. Okay. The first one is that one there. You can see that is the first one there. You can see the second one. Can you all see the highlight I'm making?
Yes, Mr. Control.
Okay. And then that one is another one there. So can you see? I am identifying them. They're mixed up, but I'm able to identify them because these are shapes. So these are your stream patterns in this diagram here. So let us look at them as individuals now. Okay, the first one is going to be, okay, the dendritic pattern. Now, the dendritic pattern, it looks like a tree and the branches. See? It looks like a tree and the branches. Look at that there. See? If you know trees, you've seen trees and branches, it does look like trees and branches. And also, it's on the uniform rock. By the uniform, we mean the medium or the type of rock that is underneath is the same. For example, if it's an igneous rock, all of this area is an area that is called an igneous rock. So that is what we mean when we say it is the same. It's uniform. And also the streams are joining each other at about 60 degrees and or less. That is at an acute angle. Also about this, you find this pattern most of the time in the upper course. Find this one mostly in the upper course. And yeah, okay. On the map, if you're looking this thing on the map, you are going to see a lot of brown lines, which is the contour lines, in an area that has got very little vegetation most of the time. That is what you must expect from this pattern. Okay, the second one is your trellis. Before I can explain trellis, I need to show you something. I am going to highlight some areas here so that you can see those. You see these streams in between them here. This area here in between. And also here in between. And also here in between. Also this one here in between. Yes. Now, a river is flowing in a valley. Valley. This is where the river is going to flow. Yes. I'm going to try to draw this thing in a 3D format. And then, yes, okay. I do hope you can see that. So these rivers are going to be flowing here, parallel to each other. They're going to be flowing here. And then these are the high-lying areas. These are the black lines I've drawn for you here. So this is a hard rock, this one. I'm not sure if that's okay. So this is a hard rock. And then this was a soft rock. That is why it was eroded by the river. And this is a hard rock. This is a soft rock. That is a hard rock. And that is a soft rock. So what do you have here? You've got a hard rock and a soft rock. Hard rock, soft rock. Where there's a river, there's a softer material. And then, yeah. So here, hard rock, soft rock, hard rock, soft rock. So what do you have here? You have alternating layers of soft rock and hard rock, soft rock. So alternating means to change. See, you see alternating layers of hard and soft rock there. That is what this statement is talking about there. That is what you must understand. And also, these streams are flowing parallel to each other. You can see the streams. There you stream, and there's another one here. There's another one here. They are all parallel to each other. And then another interesting thing that you need to know here, the tributaries. The tributaries, those of you who do not know what are tributaries, again, these are the small streams joining the river. Look at them there. They're joining at 90 degrees. You see, they're joining at 90 degrees angle. That is the angle that we're talking about, the 90 degrees angle. That is the angle. Yes. So remember, when you look at the confluences, that is where the river is joining the mainstream, most of the time you use it to determine the direction of the river. But with this one, with this type of stream pattern, the trellis, you cannot use the confluences here because they do not point downward, most of them. Most of them, they are joining at 90 degrees. Yeah, so you need to be careful when you work with that stream pattern there, determining the direction of a river. Okay, let's move on to another one. I'm just going to erase this so that I can be clear for you. Okay, now let's move on. Okay, then here we have a radial. That is radial here, there. That is radial. That is radial there. Now, radial is, I'm going to try and draw again. Radial is these are streams which are coming from a high-lying area like a hill, for example. If I can draw it for you, a hill there. And then these streams, they come, their sources are all here, and then they move downwards. on different directions, and then their sources are there, then they move downwards to different directions. Ne? So the source is in one central point, the highest point, ne? And then but they move to different directions. For example, here, look at the source of the stream here. Can you see the sources? These are the sources there. Can you see the sources? Now, but the streams are moving on different directions. This is your arrow that shows the direction of a river. That is your arrow there that shows the direction of a river. So they're moving in different directions, but they're coming from one central place. You see? Now, if you're looking at this, you're looking at obviously you're looking at a hill or a conical hill. You still remember conical hills from grade 11 and the part. So landforms like that are going to give you the radial stream patterns. The opposite of the radial stream pattern is going to be a centripetal. Now, I know it's not in this diagram, but a centripetal, it's when rivers are coming from different high-lying areas, but to meet in one central point, the low point, which is most of the time, there's going to be a dam here that is receiving all those rivers are coming from these directions. Yeah, it's the opposite of the radial. With the centripetal one, the center is where the rivers are going, whereas on the radial, the center is where the river are coming from. Okay, and then we look at the rectangular one. The rectangular, we have the streams moving on an area that is called hard rocks, like your igneous rock, for example, is a hard rock. So we know that hard rocks, when they're breaking, they don't break like soft rocks. They develop cracks and joints. If you know cracks and joints, those of you who do not know a crack, when you break a glass at home, the crack that developed there, that is the same crack that rocks develop when they're breaking. So the water is using that pathway to move, so they end up following the cracks instead of creating new paths for themselves, like rivers normally do by erosion. So these ones are actually for following the path of the cracks that are already there during the process of weathering. Now, so look at that river, it's moving. So it's bending. You can see it's bending at 90 degrees. Even there, that's a 90 degrees there. So the river bends at 90 degrees. And then the tributaries.
Sorry, Mr. Kunjwa.
Okay.
Can you please use another color because the blue is hard to see?
Okay. Okay. Thank you. Thank you, Ms. Boye, for highlighting that. Let me try to erase it. Okay. Wonderful. I'm going to try and use a red color. Okay. Look at, I was saying there, you must look at those rivers. See, they're bending at 90 degrees. Is that much better now? Ne? Look at
yes,
the angle.
Yes, it is, sir. Thank you.
Those are the angle learners we're talking about. When I say 90 degrees, those are the angles we are talking about there. And then the tributaries, remember the tributary is a stream, small stream that is joining the main river. They are also joining at 90 degrees as well. That is the angle that we're talking about there. So, and then the water flows in joints and in faults. I've already explained that to you, that when the igneous rock is breaking, because it is a brittle rock, remember in grade 11 and grade 10, you learned about ductile rocks and brittle rocks. And you were told that a Brittle rocks, when it breaks, it develops cracks. So an igneous rock is a brittle rock. So it develops cracks and joints when it's breaking. So here, because the rock is hard, it's difficult to erode, the river does not make its own pathway. It depends on what is available right for itself. Let's try and move on. We're going to now, what is important here is to know, as I said to you before, you must know what this pattern looks like, the shape looks like, and then the description. You must be able to describe it. Like, for example, it's a tree-like shape. And then the underlying structure. The underlying structure, when they talk about the underlying structure, learners, sometimes they won't use the word geology. When they say the geology, they are actually talking about the underlying structure. What is that? The river is flowing over the land. Underneath that, there's either a type of rock, whether it's a metamorphic rock or it's an igneous rock or it's a sedimentary rock. That is what they're talking about when they talk about your geology or when they talk about your underlying structure. So how the river behaves and how it forms its own shape depends entirely on the type of geology it's going through. Because if the area is a softer area, then the river is going to find its way to do more erosion. Like there in the dendritic pattern, there you can see the many pathways because that area is softer. But if you look at your rectangular one, there's an igneous rock there, so it's hard. You can't even see a lot of reshaping. It's sticking to the shape that it found there because the underlying structure is very hard. Yeah. Okay. Can we move on to a summary? Okay, let's look at this now on the map work because it's important to identify these on the map work, learners. You need to know your colors on the map work. When you look at water, you're looking at the blue color, and then the contour lines are showing you the landscapes. And yeah, so I mean, for this particular one, let us look at the dendritic one first there. Look, you can see a very little vegetation, as I said to you. This is mostly the upper course. You find this mostly on the upper course. And then look at the trellis one. The trellis, I want to highlight these. Can you see these contour lines here? In between this red color. There's contour lines there. Can you see these contour lines there? And then that is your hard layer. Remember, there's an alternating of soft layer and hard layers here. So that is your hard layer. And then that is your river there. And then that is a valley, a softer area, a softer layer. And then again, you have your hard layer there, what I was showing you at the beginning. That is another hard layer. You can see there the contour lines are showing you that there's a mountain, there's a range of mountain there. And then again, your river there in the valley. And then you have another hard layer there, if you can see what I'm highlighting for you there. All right, so you have hard layer, soft layer, hard layer, soft layer, hard layer, and soft layer. So these are alternating hard layers and soft layers in terms of the underlying structure.
Sorry, Mr. Kunjwa.
Okay.
Some of the learners are saying they can't hear you clearly.
Okay, I just got that. Can they please highlight for me where they missed so that I can go back to that?
Okay, I'll let you know now.
Okay. Sorry guys, I love what I'm doing. Sometimes I get carried over. I'm gonna try to be slow as possible. Let's just give that learner a chance. Let's give that learner a chance to be able to see where did they miss me, because this is a very important part.
Okay, so the learner
Okay.
is saying that you can continue, but please for the future, please
Okay.
try and raise your voice.
Noted. Okay. Now, we are going to look at now the rectangular one. Can you see the cracks I was showing you? The cracks there at the joints. You see the bands. Look at the bands there. You see the bands. That is your 90 degrees angle. Now this river here found these cracks here in this rock. So this area has got very hard rock. It is very resistant to erosion. So it cannot make its own pathway. It depends on what is available. So because of the geology of the area. And then now let's look at the radial one. The moment you see a spot height, remember that is a height representation. So it tells you that is the highest point. It also tells you, for those of you who still remember in grade 9, you were told to look at the cycle of those contour lines there, which shows you that is a hill. So look at the sources of those rivers. One there, there's a source there, there's a source there, there's a source this side, there's a source as well, there's a source. So they are all going into different directions. They are all going to different directions, coming from one central high point. This is a central point they're coming into. Yeah. And you can see there are farmers there waiting for the water to come down. You see there are farmers there waiting for the water to come down. Yeah. So that is how you look at this in the map work. Okay. And then let's move on. I'm going to, here on the summary, I am only going to look at the ones that we have not mentioned in the previous slides, which is your deranged pattern. The deranged pattern has got another name that I think I'd like you to note down. It's called the irregular pattern. I know some other textbook will have that word there. And then this one is found in the lower course. The slope where this river system is happening, it is a very flat slope. If you're pouring water over the desk or on the table, if the table is flat, the water is gonna just sit there or move in any direction it wishes to. It will not have a specific direction it's taking, because the slope is flat. Same applies to this one. If you can see there are small dams there. If you can see, those are small dams there which have formed because the water is trying to collect itself into one place. Probably those are low-lying areas in the area, but you can see there is no proper direction where the river is going. You cannot tell if whether this river is going at what direction, because it is irregular, it is deranged. So these are most of the time small streams. Okay. Yeah, I think we spoke about parallel, we spoke about centripetal. That is your centripetal I was talking about initially when I was saying it's the opposite of the radial. Look at the dam and the center. They are coming from different high-lying areas, and then they are going down to meet there in that central point. So that is your centripetal one. Yes, they are flowing into the lake. The other ones, we did discuss them. I propose that we move on. Okay. How to identify centripetal on the map? Okay. The easiest way to identify centripetal on the map, you need to look at the different mountains. Obviously, you're going to have a river, different rivers which are coming from different directions, meeting maybe in a dam, if you can see a dam or a lake where many rivers are coming into, then you should know that is your centripetal. I'm not sure if I've answered Stole there. You will indicate if I've answered your question clearly. Stole was asking how to identify centripetal pattern on the map. So if you see it, because they are all collecting to a dam or to a lake, so you'll just look if there's few rivers coming into this lake or dam, then that should know that it's your centripetal. Okay, he says fine.
Mr. Kundra,
Hi.
I have attached a picture for them in the group for the centripetal.
Yes, thank you so much, Mom. There is a lake Rukwa there. They can see it there. Yeah, very well. It's clear. Okay, thank you so much. All right. Can you please do that activity for us, Miss Popia? Over to you.
Okay, learners. For this activity, I need you to identify 3 patterns, which is the dendritic, the trellis, and the derange. So I'm giving you 5 minutes. We are using the same procedure. All the answers must be forwarded to the WhatsApp group. Thank you. I see the activity requires learners to make sketches. So can you please just make the sketches and send as the pictures on WhatsApp?
We are going to look at the stream orders. Now, learners, this is a very easy concept, but most of the learners, they get confused. I'm going to tell you this thing. The first thing that confuses you is how you do your math. When you are counting, do not use the maths rules. They do not apply here. Here, 1 plus 1 is 2, and 2 plus 2 is 3, and 3 plus 3 is 4. So, and 3 plus 2 is still 3. So I'm just giving you an example. That is why learners are finding this thing difficult. Okay, before we get there, let's just go straight to the point. The stream orders, they help us to be able to know the drainage density of the river system, which actually help us also to estimate the amount of water we can probably get from the river for those for the people who are planning in the water budget. So this is a very important task. I'm going to show you in a very simple way on how to tackle this. The first thing, learners, you need to do, look at all the sources. The sources is where the river begins. For example, here, can you see that highlight there? That is your source. So there are all sources around here. Take your pencil and then you make all the sources to be order number 1. I don't know what is happening here. Let's go. Okay. So you take your pencil and then you make your, let me just get a pen for you there. Okay. You make your sources to be order number 1. There's your order number 1, the 1, and then there's 1 there, and then there's 1 there. Is the color clear enough? Can you guys confirm if the color is clear?
It is, sir.
Okay. So there's also 1, order number 1 there. Wherever you see a source, put in number 1 You can see there, putting number 1 there, putting number 1 there, and number 1 there. You do all of them, and number 1, where you see a source. Now, once you are done putting the first orders, you need to look at the confluences. Remember, a confluence is the point where a stream is meeting another stream. I'm going to start on my right hand side. I don't know what's the right hand side on you. I'm going to start there. Look at that confluence there. Can you see the confluence? I'm highlighting it there. That is a confluence. This is where this stream and this stream are meeting. Only after the confluence do you write the following order. So here, for example, there's order number 1 is meeting with order number 1. They give you order number 2. Is that clear? And then here, there's order number 1 there. Order number 1 is coming all the way, and there's a confluence there. It's meeting with order number 2. When 2 orders meet, the following stream takes the order of the bigger order, which is, in this case, the bigger order is order number 2, and the small order is order number 1. So after this confluence here, in this area here, I'm going to take it out a bit so that you can write clearly. We still have order number 2. And then you've got order number 1 again, meeting up with this order number 2 in that confluence there. That means we continue with 2. So I hope that one is clear. And then let's go over to that part. And then you've got order number 1 and order number 1 meeting. They give you order number 2. There's order number 2 there. Okay, so you've got order number 2 meeting up with order number 2 in this confluence here. And then you've got order number 3. Can you see? If you've got 2 orders with the same number, they produce the following number. Okay. And then let's now go back to another one. There you see that is order number 1. There is order number 1 is coming all the way to come and meet in this confluence here with order number 3. So which means here we have got this stream as order number 3. Okay, let's go on to the other side of the mountain. There we've got order number 1 and order number 1 meeting in that confluence there. They give you order number 2, and then go down. There's order number 1 there meeting with order number 2. Remember again, when order number 2 meet with order number 1, order number 2 takes the following stream. So which is order number 2. We always take the bigger number. If the numbers are not the same that are joining, take the bigger number on the following one. So the number doesn't change, doesn't become 3. You just take the Sorry.
One of the learners is asking if you can change the highlighting color.
Okay.
I don't know, maybe you can try using black.
Okay, I asked that one, but it's fine. I'm going to try to use black. Can you see now? Can they see black? Can you confirm that you can see black? I just wrote 2 there. Let me try yellow. Okay, thank you.
I can see black.
Okay, thank you. We can move on. Okay, so you have 2 there. And then now remember this. Okay. Let me remove this 2. I don't know why there's a 2 here. No, why there's a 2 here. Okay. Okay. So if you go down, you have order number 2 meeting with order number 1. On that confluence, they give you order number 2. Yes, is that clear? Because this order and this order, they were meeting here in that confluence, and then we take the bigger number there. And then you move on to come to this side. You see order number 1 there, meeting with order number 1 and that confluence there. You see? And then they give you order number 2 because 1 and 1 is meeting. So here we've got order number 2 and meeting with order number 2 in the confluence there. They give you order number 3. Order number 3. Okay, now order number 3, if you go down, there's a confluence there, it's meeting with what? There's order number 1 there. So order number 3 is meeting with order number 1. So we maintain order number 3. And then here now in this confluence, you've got order number 3 from this side and order number 3 from this side. Then they meet here and then they give you order number 4. And then order number 4 is another confluence there. It's meeting with order number 1. So at the end, the order of the stream is order number 4. Order number 4. Okay. So the stream order of the stream is order number 4. Okay. You can see there's 4. Okay. One thing though that you must make sure you don't miss, if you have 1 and 1, they give you 2. If you get 2 and 2, they give you 3. But if you've got a bigger number that is 3 and 1, they still give you the same bigger number. So nothing changes there. You see, you even have 3 and 2 there. See, they give you what? They give you 3 again. But if you have got 3 and 3, they will give you 4. So you just need to be careful of that. I don't know if there are any questions. Please, learners, we can only use a common language that is heard by everyone else. If you do not understand anything, you can just pose a question. We are going to try to be patient and answer to our ability so you can understand. Okay, let's take that activity. Ms. Mbopia, can you please take over from here? Please let us be advised, we have only less than 15 minutes left before the end of our session. Can we try to see if we can finish this one in 2 minutes so we can have something else done? Thank you.
Okay, learners, can you please do that activity on your screen and send your answers on WhatsApp? Remember, if you are adding the same number, then you add a 1. If you are adding 2 different numbers, you take the bigger number. So if you are adding 1 and 1, then you add, and then it becomes a 2. If you keep adding 2 and 1, then you take the bigger number, which is 2. If you are adding 2 and 2, then you add 1 on the 2, then you get 3. I hope it's clear now. Okay, so far we have a common answer. We have Badale with 4, Fulani Tech 4, Fairdale number 2, 4. Delft High 4. Fulani Technical 4. Fulani Tech 4. Okay, so we still have the common answer, which is 4. Good.
Okay, I think most of the schools got it right. It's actually there's one there and there's one there. There's one there and there's one there. One there. There's one there and there's one there. So you have got two continues there. Then you have two again. You have two even here. So you end up with two again there. And then again you've got one, 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 one there. That is two there, and then there's two here, and then there's two here, and then there's two there, and then you've got order number 3 here. Okay. So again to the other streams, 1, 1, and 1. You've got order number 2 there. And then here, let's see, 1, 1, and 1. Also you've got the number 2 there. There's 1 there. So you've got order number 3 there. Okay. And then you've got 1 and 1, 1 and 1. Okay, you've got order number 2. Got order number 2. Then you've got order number 3. Then you have 1 and you have 1. Then you've got order number 2. And then you have 1 there, 1. They give you 2. Then you've got 1. And then 2 we carry on. You've got 1, and then you have 1, and you have 1, you have 1 there, and then this one, so will give you 2, and then 2 will carry on there, and then 2 will carry on there. This gives you 3. All right. So these ones, there's a conference here, they're going to give you 4 there, 3 and 3. And then here you get your 4 continuous. And then here and 4 and 2, 4 continuous. And then here you've got your 4 at the end. So the stream order is 4. All right. Thank you, guys. We have about how many minutes? 5 minutes left. So I just want to see if I can be able to look at something before we can move on. All right. Another thing is, can you confirm if you can see the next slide for me?
Yes, Mr. Kunja, you can say it.
Okay. We have a discharge of a river. Now, the river discharge, by definition, learners, we are looking at the amount of water passing through a point in a river in a second. This is, okay, I'm going to try to make this definition easier for you if I can. I'm going to try to draw a small river here. It's a small river there. Your small river there. And the water is flowing there, if you can see. When I say in a point, let's say there's a something that is standing there, maybe a house. So that is the point I'm talking about there. How much water is passing here as the water is flowing in the river? Water is flowing in the river, inside the river. How much water is passing here in this particular point per second? So that is the discharge that we are looking for here. Obviously, it determines the amount of water, especially if most of the time rivers, they end up going to the dams and everything else. So if you're going to build a dam, you need to know the capacity of the river. So that is measured in different ways, which is in grade 12. They don't necessarily look at how you measure the river discharge, but I'm just letting you know. Okay. Now the river discharge then comes up with two types of flows as the water is flowing. You've got your laminar flow, and then you've got your turbulent flow. Now, the laminar flow is a quiet water, a water that is so quiet, it's not rough, it's not dangerous when you look at it. So the flow of parallel sheets, okay, which means the water, as you can see there, by parallel sheets, what are we talking about? Sorry, I'm panicking because of time, because I really want to explain this. If you throw a stone in the water, you are going to see the layers of the water moving. So each and every, I don't know if you can see that. It seems like they are sort of like broken, something that you are peeling off. I don't know if that is clear. But those are parallel sheets, which means the water is flowing peacefully. All water sheets are flowing nicely. Nothing is disturbing each other there. And then the reason for that is because the riverbed is even. What do we mean when we say the riverbed is even? It means the riverbed is smooth. Ne? The riverbed, remember that is your riverbed. It's smooth. The water is not bumping in anything there. That is why it's not rolling. That is why it's not rough. So it's not bumping on anything. So it's flowing quietly and so smooth. And also because this water is not violent, there is less erosion that is happening there. Most of the time you find this in the lower course because the slope is not steep. Remember, the steep slope gives water energy. So the slope is not steep, so it doesn't have much energy to flow faster. And then you've got your turbulent flow. As you can see there, the water is so rough. And then the riverbed is because the riverbed is uneven, which means there are things in the riverbed that are not straight, so the water is disturbed. And also there is more erosion there because the water has got energy, is moving faster, and then it's found in the upper course. So that is mostly what this type of flow is going to be. Learners, I think our session for today is going to end here. Thank you so much thank you educators for